This is Orhan Ergun. Today with me, Mohamad Radwan, and we will be talking about ISP merge scenario. So there will be more than one service provider, and we will discuss the merging scenario. So real life discussion it will be, another real life discussion. So far we discussed in the real life design mostly enterprise and large scale data center design, RFC 7938, those kind of things. And Rift we discussed some real life deployment with the inventor of the protocols, those technologies. Today service provider discussion we will have. And as I said, Mohamad Radwan with me. Mohamad, welcome, and can you please introduce yourself?
Yes, hi everyone, and thank you, Orhan, for the invite. And I'm really excited to be with you. Yeah, we've been working in Qatar for maybe 6 years ago, but I'm happy to meet you again face to face. My name is Mohamad Radwan. I've been working in the industry for the last 20 plus years, most of it in service providers. So I worked in multinational service providers like France Telecom, and I work with Saudi Telecom in the Gulf, Qatar Foundation, and I moved to Australia recently, last 4 years, and I've been working with Cisco and Vodafone here in Australia. So as you can see, most of my experience in service providers, but I've also worked in a couple of cloud service providers as well. That's why I also have some knowledge about security, cloud, SDN, and NFV. As Orhan mentioned, today we will discuss one of the scenarios, real-life mega project, which I handled from architect and design perspective. It was a merge between 3 service providers. So actually, one service provider acquired the other 2. So this main service provider was mainly having some mobile customers along with some internet services, and that's it. And then they have decided, in order to expand their footprint, increase their coverage, and in order to have new customers, and everybody now is trying to be one-stop shop. So you go to this service provider. If you are a residential, you get your mobile, your internet, your voice and video, and also they acquired another service provider which more into business, providing MPLS services like layer 2 VPN, layer 3 VPN. So this is as a quick overview about these 3 customers and what were the main requirement for having this merge acquisition.
So
before we start,
we will deal with the. By the way, just a second. Yeah. Now they can see me as well. When they see me, I am more relaxed now. The point is, we will discuss the interoperability between the providers, the scalability of the entire acquisition, it seems, and some SLA requirements we will have a look, and traffic engineering, it seems, TE we will discuss, and some limitations was there, I think, hardware limitations. We will discuss that one as well, right?
Exactly, 100%, Orhan.
Okay.
And as Orhan said, I believe maybe let me and Orhan speak for maybe almost an hour, explain all the challenges and how I just come up with an optimal solution. And maybe in the last 20 minutes or so, we can answer your questions. So maybe you can post it on the chat. And I prefer to keep it till the end, if you agree, Orhan.
Yeah, definitely. Please ask your questions by using your microphone at the end of the session. But if you have questions, just in the text window, chat window, you can type it. And Mohamad, you can continue and I can answer the questions.
Sure, great. Thank you very much. So, as we mentioned, let's go to the next slide.
It's not changing.
Yeah, I'm still new with this GoToMeeting, so
yeah. Actually, they changed They changed now
maybe,
this phase.
Just from high-level perspective, usually when you work in this mega project, there are the normal phases: planning, design, and implementation. But I've added a very important phase, which is a proposal phase. So once you get engaged into the proposal, and fortunately, and for the best of this project, it was really nice and really beneficial that I have been engaged even from the first meeting with the customer. So this really make a huge difference for the project execution. So, and I will discuss it in the lesson learned section. So when I was engaged, when you engage your main architect or the designer team as early as possible, maybe during the data gathering, during the meeting the customer executive even, you will start understanding what are the business requirements. So this was a key and very important success factor for this project, because we were engaging the architect team very early in the proposal. Also, during the proposal phase, we were able to show the customer a demo of what is our plan of the merge, what are the building block of the solution, and we test some use cases. So this demo, again, was also a very important thing which we did during the proposal phase. That's why when we helped our sales team to prepare the proposal with the hardware, with the migration approach and the merge approach, it was actually almost very close to what we did in the project itself. So this is one of the most important point I want to highlight about the proposal phase.
Mohamad, let me tell you something. We still see this SP merge challenges slide, not the another one.
Really?
Yeah. Can you change the slide? Go to another one.
For me, it's the proposal slide.
Yeah, I realized you are talking about that, but still we are seeing this one. I think it's changing now. Not yet. Empty screen at the moment. Maybe open, just close it and open again.
Yeah. Let me stop. Is it okay now?
Yes. Proposal.
Yeah. So this is the main point I want to highlight: proposal phase, which will actually be very beneficial for anybody working in this such mega project. Then during the planning phase, you need to meet the customer again, meet the stakeholders. As I mentioned, do some design workshop and assure that you document the customer requirement. And after that, you can start working on the design phase. And during the design phase, again, start working on the actual design and do some testing to make sure you're meeting the customer requirement, and finally implement as per plan. Let me go to the next slide and let me make sure. Just tell me if you can see it. So can you see this proposed architecture slide?
Yes, I can see now.
Yeah.
And now we are starting some technical stuff anymore.
Exactly, yes. Now we start the fun.
Yeah. What these service providers also, they have internally like IGP, maybe BGP, etc. You can explain, like maybe they have full mesh IBGP, configuration route reflection from the BGP point of view, IGPs. Let's talk about if they have MPLS or segment routing or whatever.
Yeah, sure. We will cover all these points. So, yeah. Okay, so let's say we have 3 service providers, and each service provider, we will name it service provider 1, and we'll just give it an IGP, BGP autonomous system number as 65001, just imaginary number, because this is a private, not the real one. And service provider 2 having autonomous system number 6502, and same as service provider 3, 65,003.
Which one is acquiring another one? We said acquisition. The one service provider will acquire another 2 service providers. Which one is acquiring other 2?
Yeah, so service provider 1 is mainly mobile and internet.
So internet, fixed or mobile internet?
Yes, mainly mobile broadband and providing mobile service. Acquire an internet service provider, and mainly internet and IPTV and some voice services. And the service provider was mainly business, MPLS, VPN. So layer 2 and layer 3 VPN services. Okay, so this service provider 1 acquire service provider 2, and service provider 3. And as Orhan said, each one of them has its own IGP. So let's imagine this one is OSPF, this one is ISIS, and this one was also IS. Okay? This is just a simplified architecture, but actually this service provider was much bigger and covering a huge area. And because of the NDA, I will not be able to tell the location or even the name of service provider. But as you can see, we have different IGPs. We have different even vendors. And to make it easier for you, I tried to put different icons. So the core router are here in gray, and the PEs in blue, and the ASBR in black. So let's take it one by one. So as we mentioned, we have these 3 different service providers, and we want to make something like seamless MPLS. So what is seamless MPLS and what we are trying to achieve with it? With seamless MPLS, we want to make sure that a service in this PE will be able easily to have another service with a PE in the domain number 3 in an easy way. Maybe in the old legacy part, maybe one of the solutions that maybe this service provider will agree to have what we call it NNI, network interconnection. So they can maybe have like a trunk, they have a switch here, a switch there, and just connect this switch with a layer 2 trunk. And if they want to extend the service, they want to make sure that this service will configure as a VLAN here, and then they will have another NNI between service provider and service provider 1 and service provider 3, and also will extend a VLAN here. So in order to provision a service without seamless MPLS, we need to create a service like this and stitch it through this NNI, and then carry it over the second service provider to the other NNI, and from the third, this last switch to the third service provider. So as you can see, provisioning services will be very complex, will be very time consuming, and will cause a lot of problems. So we need to touch 3 network plus 2 NNI. So any mistake in any of these 5 provisioning will cause it a big problem. So that's why people start thinking of how to make sure that the MPLS label will be, or the MPLS, what we call it LSP, label switched path, will be extended from one service provider to the egress service provider in an easy, automatic way. Just to make sure the term LSP within a single service provider, this is happening. So as we said, we have here OSPF. With OSPF, we are sharing all our point-to-point links. We are sharing our loopbacks. So these devices can reach each other. Then we need to have a protocol to exchange a label, advertise the label, and accept a label from our domain. That's why we have we can exchange label with LDP, RSVP, or BGP. And we can have another session talking about what is the best use case to use each of this one. So after having this label switching protocol, a router here will be able to establish an LSP within domain via exchanging label one hub to another. So if we take this concept what we need to do with Seamless MPLS is we need to build what we call it a hierarchical LSP. So instead of doing all this stitching manually, we need a protocol to extend the LSP from one domain to another. So let's say here we have LDP. We are building the LSP within service provider 2 using LDP. And also here we have LDP, to make it simple, LDP for the 3 domains. So each domain can build its own LSP within the service domain or autonomous system itself. Then it will be the job of BGP-LU, BGP label unicast, to make sure that these LSPs are extended in a hierarchical fashion. So using eBGP-LU, we can carry on the remaining labels from one LSP to another. So the overall picture that taking all these LSPs and connectivity between BGP-LU will have an end-to-end hierarchical LSP from PE1 as example here to PE10 in service provider 3.
Okay.
Before carrying on, do you want to add anything, Orhan?
Yes.
Is it clear?
There are many things. Let me add. So guys, so far, maybe for those who already know inter-AS MPLS VPNs, who already know Seamless MPLS in a single BGP autonomous system, what we are doing here is we have 3 different autonomous systems, and in fact, there is an acquisition. So SP1 is acquiring SP2 and 3, and then connecting those SP2 and 3, it's using, we can call this one inter-AS option C. So we are having BGP-LU RFC 3107 or recently updated 8277. So
Yes.
what we are doing with the 3107, this BGP-LU, BGP label unicast, BGP plus label, RFC 3107, same thing. We are advertising PEs, ASBR, if there is route reflector, those IP prefixes. Don't forget, IP prefixes, IPv4 or IPv6 prefixes between the service providers. Why? Because end-to-end SP3 ingress PE, let's say, at the very left side, can reach to SP2's egress PE end-to-end. So IP connectivity is there. Now, when you look at the SP3's ingress PE, what's the BGP next stop? SP2's egress PE end-to-end. So you don't have to touch any device in between. You don't have to touch the ASBR on SP2, SP3, nothing. Just you need to touch the ingress and egress PEs. That's the whole purpose. So far, probably those who already know, as I said, inter-AS MPLS VPNs and Seamless MPLS in a single BGP AS, we are not doing that. We have here 3 different ASs, and we are still doing inter-AS MPLS VPN, as you can see here. And why we call it Seamless MPLS? We have end-to-end unified MPLS, which means just MPLS control plane with IP, of course. Without IP, you would call it MPLS TP, whatever. So with IP plus MPLS, we have end-to-end. We don't have to deal with any terminating layer 2 here, then placing in a VRF, then do this, do that. We want to reduce to touch point, and we want to eliminate number of protocols. Just single protocol MPLS control plane here we have, and IP, of course, control plane as well. And end-to-end, we will have simplification. That's the reason why we are doing this simplification. When we want to have service from one end to the other end, we don't want to touch each and every device. We don't have to have protocol translation, those kind of things. I wanted to add that BGP-LU, don't forget, assigning a label via BGP to IP prefixes, not VPN prefixes. It is different, Afisafi. We are talking IPv4 and IPv6 in this design. We are not mentioning IPv6 yet, but BGP-LU can assign the label with the BGP to IPv6 prefixes as well. Let's continue.
Thank you, Orhan, for that. Yeah, as we mentioned, in the first case, when I told you without Seamless MPLS, we had to touch maybe 5 points. We had to touch the PE and all the NNI and the final PE. With Seamless MPLS, we just need to touch the endpoints of the service, PE1 and PE10. So this is a huge success. As Orhan said, to have this ABGP-LU, we have multiple inter-AS options. So we have option A, option B, option C, and option AB. When we come to a decision, we said option A, even if it's the most secure option, but it's not scalable because each autonomous system border router will work as a PE and will consider the other as a CE. And this means for each customer, we need to have a VLAN and configure the VRF, so it's not scalable. So that's why we eliminated option A easily. And then we have to decide between option B or option C. Option B means that the ABGP-LU will be between the ASBR, as you can see here in the diagram. So this is the black boxes are the ASBR, or this is option B, between the ASBR. Option C, we will have the ABGP-LU between the route reflectors. So in our case, some of these service providers, because it was a small service provider, didn't have a dedicated route reflector on all the regions. And because it was a bit complex to convince all the team managing the route reflector in the other domain to work on that and check the support of. Sorry,
did I miss something? Because I think you said for the option C, running ABGP-LU between the RRs. You said that?
No, actually, we decided it's option B here in our implementation. That's why I wanted to correct this point. So it was option B between the ASBR. This was, in the project, usually we have phases. So we agreed as a quick win and just to complete this merge as soon as possible to start with option B. And it was planned in the future, we need to introduce, make sure that the RR are available in each domain and support this BGP-LU. Then it will be as a second phase to move from option B to option C and move this integration between the RR itself.
But when you have between the ASBRs, when you have option B, you don't have BGP-LU between the ASBRs. You have VPN v4 station between the ASBRs. So you started with the VPN between the ASBRs first, then moved to BGP-LU?
No. Yeah, it was BGP-LU. So this ASBR, what is the functionality it will do? Because it was a dedicated device. So the main function of this ASBR is to make sure to advertise all the PEs loop back from one domain to another domain. Okay? Yeah, and all the other ASBR will do the same. So by doing this, the PEs in service provider 1 will be aware about the loopback of this PE1 as example because it received it from this. So let me complete the picture. So here we have ABGP-LU between the ASBR. And to extend this LSP to the other domain, we have two options. And then I will tell you what we decided. We have option to extend the BGP-LU to all the PE. So this means we will have like IBGP-LU. So let's say we don't have route reflector. Let's say we have because we have multiple cases we have for the region. If we don't have a route reflector, so this means that this ASBR will need to have another session with each PE using the IBGP labeled unicast. Let me tell you something. When you configure BGP, we have the concept of address family, and we call it address family index, and we have the concept of SAFI, subsequent address family index. So let's say I'm having a peering with this router because I'm supporting, as example, IPv4, maybe for internet as a BGP. I'm supporting VPN v4, okay? So these are the address family. And under this address family, I can configure if I need unicast or multicast or label unicast. So if unicast is SAFI, so unicast is SAFI number 1, and label unicast is SAFI number 4. So what you need to do, you need to add a neighborship using BGP label unicast with all the PEs. So these PEs, let's say, will know about the other PEs from the other domain. So this means that all these PEs shall support the address family, which is SAFI number 4, which is BGP label unicast. Let's take the other domain, okay, and let's consider for as example that one of these devices, couple of the PEs here, doesn't support BGP-LU. So in this case, we had to implement the other option, which is this ASBR will get to know all the loopbacks of all the PEs in service provider 1 and service provider 2. And he needs to inform all the PEs in his domain about these PEs, but he cannot extend BGP-LU. So what he will do, this ASBR, it will redistribute from BGP-LU to ISIS in this case, and by doing this, these PEs will be able to aware of the loopback of the remote PEs. So is it clear so far? So what we did, we decided to go with enter AS option A for the domain which do support where the PEs support BGP-LU. We extended BGP-LU till the end, till the PE. So this means eBGP-LU between the ASBR and iBGP-LU within the domain. For the domain or the autonomous system which doesn't support BGP-LU, we had to go with the other option, which is redistributing the BGP-LU routes from the ASBR into the IGP. And of course, we need also to redistribute from ISIS the loopbacks to ASBR, and then ASBR will send it to the other domains.
Okay, so far so good. Let me tell you something now. Okay, now what you are saying, good. With intra-AS, if it's supporting iBGP, label unicast, so you are using it. If it's not, so you are doing a two-way redistribution from IGP to BGP and BGP to IGP. Only point here, between the ASBRs, of course, it's eBGP, different autonomous system. eBGP labeled unicast you are doing, that's okay. But you are calling it option B, and I think it should be option C, because when we have between the 3107 BGP-LU between the ASBRs, it's option C. If it would be option B, then we would have VPN session between the ASBRs. Other than that, everything's clear for me. Okay.
Exactly. Cool. I don't want to call it any of these options. That's why I believe it's different. The right name is we call it Seamless MPLS.
In fact, I would agree with you on that, because otherwise, normally we wouldn't use iBGP within the autonomous system. iBGP-LU we wouldn't use. So this is a little bit special. But if we are categorizing the interest options by looking ASBRs and what we are having on the ASBRs, just categorizing in this way, then this would be option C, because option C, between the ASBRs, we exchange the IPv4 or IPv6 plus label. That's why.
Yeah.
Okay, good.
So let me carry on, but I will try to just maybe I want to remove all of that. And...
Are we having fun, guys, while we are at home? Huh? Let me see the feedbacks. You can type in the chat window. Do you understand what we are talking about? Great use of time. Yes, good scenario. Oh, good. Okay. Nice to hear. Let's continue.
Let me clear it again and let me revisit a couple of points. So there was a lot of challenges here in this project, and let me discuss some with you. So one of the points, as I mentioned, is the support of this BGP-LU address family. I want to highlight an example. It depends per vendor, or even to be specific, per hardware, as we mentioned, because BGP is architected like you have when you configure BGP, you go to router BGP, then you configure the common configuration, and then you start doing some configuration under the address family. So as example, you mentioned address family IPv4 unicast, and you start doing some configuration specifically for this address family. But because under the, let's say we are still in IPv4, under the IPv4 address family, you have multiple SAFI. You can have unicast, as I mentioned, multicast, flow spec, and label unicast. Depends on each hardware and each vendor, the separation between the SAFI is not 100% complete. So let's say, let me try to draw something here. As we mentioned, we have BGP, and under BGP we have AFI, address family index, and under the address family index we have SAFI. So let's say in our case we have IPv4 unicast and IPv4 label, or let's make it LU easier. So here, depend on the support and how the feature parity in each router, we will be able to decide what shall we do. Let me explain. So if there is a separation, a complete separation between IPv4 and unicast and IPv4 label unicast, you can do some specific control for label unicast, which will make your life easy. But for some other vendors and some other hardware where you cannot do this separation, so as example, if you apply a filter for IPv4, it will be applied for both SAFI, for unicast and label unicast. That's why you need to be more granular and you do the control by yourself. Let's take an imaginary situation. Let's say this ASBR actually wasn't a dedicated ASBR and was a normal PE, which has an internet service and a couple of layer 3 VPN. So this means that this ASBR already has some services and have some BGP neighborship and already having the full routing table of BGP. And then, because here, as we mentioned, the PEs doesn't support BGP-LU, we need to redistribute from BGP to ISA-S. So if this device was very intelligent and support all the features, we can tell him only redistribute the route you will learn from label unicast neighbors. Okay, so this is the easy way. But let's
how many prefixes we are talking about, Mohammed?
Let's say for label unicast we have maybe 5,000 labels, 5,000 PEs. And for internet routing table, we have millions of routes. The challenge is if you tell this router redistribute from BGP to ISIS, and that's it, you are having a big risk to your network that ISIS will die because you are advertising millions of routes. So
even 5,000. Did you redistribute 5,000 prefixes to ISIS?
Yeah, so let me repeat. What I'm trying to do, Orhan, I'm trying to redistribute the PEs loop back only from BGP.
Yeah. It is clear and it is important to get the point, guys. So internet prefixes also coming there, and today IPv4 default free zone 800,000 prefixes we are talking about. So we don't want to advertise, of course, those 800,000 into ISIS. So this SP3 domain is not supporting IBGP-LU, and we need to redistribute to ISIS, so then PEs end-to-end can reach to each other. So SP3 PE can reach to SP2 PE as well through the SP1 core, so on and so forth. But what I'm saying is, even if we have 5,000 PE loopback overall, and each and every device needs to know those 5,000, you are advertising then 5,000 to ISIS. Did you advertise 5,000 prefixes to ISIS? Guys, mute yourself. What's this? Mohammed, can you hear me? I muted Mohammed as well. Just a second. I mute everyone. Mohammed, okay. Interesting. People just want to talk. I just unmuted yourself, Mohammed. Go ahead.
Okay, yeah, thank you. Yeah. So yeah, as you mentioned, Orhan, correctly. So I'm just trying to give everyone how the designer can be flexible and architect. So let's say we wanted to redistribute only the PE's loopback. And as I mentioned, these PE loopbacks we have learned through BGP-LU neighbors. So when we redistribute from BGP to ISIS, it depends on the vendor. Some vendors support to go under, when we redistribute from under ISIS, so I will say redistribute BGP, and I will be specific and I will mention just redistribute the routes learned from this segment. So this will make sense and will make the configuration easy. But what if, and we face it, some of these ASBR doesn't support this granularity. Under ISIS, the only option I have is redistribute BGP. So in this case, we have to do it the hardest way. We have to create like a prefix set, include all the loopbacks from the 3 domain, and only redistribute these prefixes into ISIS.
Not prefix set, prefix list, right? Prefix set. Yes, now iTouch will be very excited when he hears prefix set. So yeah. Segment routing he loves. Okay, go ahead. Go ahead, please.
After redistributing this specific, we are solving a problem. So this will happen to in your real life. So as example, you are planning into your architect, you put your design and you are expecting to do that, and you did it the first time, it was working perfectly.
What?
Then you start deploying this solution into all the other ASBR, then you discover that one of them is having a limitation. So that's what I meant about hardware limitation. When you face a hardware limitation, don't panic. Just take a breath, and think about another workaround to meet your end goal, and try to make it as scalable as possible because you will apply it in other places as well.
Okay, 2 questions now. Let's clarify those. We redistributed to ISIS those BGP-LU prefixes. So BGP-LU, what it carries? The PE loopbacks, if there is RR, etc. Those infrastructure prefixes, we call it. It's carrying those prefixes, and we redistribute to ISIS. And what was the reason these guys didn't support BGP-LU? Software, hardware limitation? What was the problem here?
You're talking about the PE or
PEs. PEs.
Yeah, the PEs here was very old. The vendor doesn't support this BGP-LU. For the ASBR, the ASBR itself was supporting BGP-LU for sure because it was working. But as I mentioned, the granularity and separation between BGP-LU address family wasn't up to the level. So for this specific hardware, specific version, when you redistribute BGP, you cannot specify, I just want to redistribute BGP-LU. You either redistribute BGP as a whole or not. So that's why we had to do this tweak and work around redistribute BGP with a prefix set. But the problem with this workaround that whenever we have a new PEs, we need to go to this prefix set or update it, or because most of the service providers are very smart and planning ahead, usually they have a dedicated subnet for loopbacks, so you can just put this subnet into the prefix list, and whenever you add a PE, it's already there.
Yeah. Like assign/22, whatever /21 already from that subnet prefix list, you don't have to touch every time. Another one, what if you will have IP address overlap with of the PE device loopback between the SP3 and SP2? Other than that, what you will do? So you were lucky that you didn't have the IP overlap. So there was a couple questions about that. I answered in the chat window. So you didn't have any overlap. You didn't deal with this kind of issues, right?
Exactly. Actually, it's one of the point I prepared. You're reading my mind, Orhan. Yeah, exactly. And I was going to ask the audience because a lot of people used to ask me this before, especially when I was working in some small service provider. They used to tell me, we believe it's stupid to assign a public loop backs for your PEs, for your infrastructure, as Orhan mentioned. And I told him it's not stupid. It's case by case. If you are having a huge service provider and you are thinking that in the future maybe you will merge with other service provider, or you want to give your customer the freedom to use whatever 1918 or private IP address they want. Some of the old big service provider usually prefer to have a public IP addressing for their specific loopbacks, and some of them they have it also for the loopbacks and point-to-point. Fortunately, for this project, the three service provider wasn't overlapping. Two of them was using public IPs, and the third one was using private, but it was okay. We didn't face this challenge. But here I want to highlight, you cannot say that any idea is stupid because based on the requirement, maybe this idea makes sense. If you read Russ Wyatt, the art of network architect, he mentioned one of the cases that a financial enterprise, they laid their own cable from America to Europe just to save a couple of milliseconds. But for some people, they will say this is stupid. But over maybe 10 years, the return on investment was huge for this company.
In fact,
so what you consider stupid for your case, maybe it makes sense for another customer or another case.
That's right. And in fact, that when you said for the financial network reducing the latency, among the audience now, I see Ramiro there. So we did some real life discussion also, like you, with Ramiro as well. And they have large financial network, actually global financial network, I should say. And they are using those Hibernia subsea cable system, etc. They are paying, of course, a lot of money compared to other routes between the US and UK, etc. But reducing the latency by, they know that they need to pay more, but getting advantage of propagation delay because distance is lower than other subsea cables. Anyway, so far we are good. It's understandable. We talked about the IGPs, we talked about the BGP-LU between the ASs, we talked that if there is IBGP-LU, if it's not supported, we need to redistribute, and doing the redistribution, we shouldn't advertise full internet routing table, so we need to segregate those subaddress family identifiers. So just for the BGP-LU should be redistributed. So for that one, if there is no granularity on the ASBR to advertise only those prefixes, we need to create a prefix list. So far so good. What else and also we talked about if there is IP address overlap, you could come up with a couple solutions. In fact, you could change the IP address schema, of course, or you should you shouldn't do NAT, but better idea would be changing the IP address space, and it would open another discussion such as assigning public IP address versus RFC 1918 space. There are some security discussion could be, another discussion could be IPv4 public address exhaustion, etc., etc. Let's not go there. Let's stay on this topic, and what else we can talk about this acquisition.
Yeah, exactly. Yeah, I prepared a couple of design decisions. Let me try to make sure that I can move to the next slide.
Sure.
Okay, so let's discuss a couple of this design decision again. So I don't want to touch on the first one because of time limit, and maybe we can have another session with Orhan, because service provider, when it comes to IGP, some of them say, shall we go for ISIS or OSPF?
Oh, this is big. This is big religious discussion now. Let's not do that. Yeah.
Yeah, exactly. Yeah, I would just want to discuss with you 3 points, which also was part of the project. And I noted that we are almost hitting the hour, so I'll try to be more quicker. And if needed, we can have another session to carry on with this scenario, which was really a large project, mega project. So yeah, first point, there was a challenge. I will discuss the third and fourth first, and then we come to TE because I have it in a specific diagram. Can you see my screen again?
Yeah.
So here, one of the challenges is quality of service. When we start working on this service provider, we discover that the quality of service they provide to their end customer is completely different. So some of them, specifically the mobile service provider, because it has very less quality of service. He has maybe EF for mobile core, and everything else is best effort. Here, because it's business, it has multiple classes, and they can offer to the customer up to 8 classes. And within core, they have all the 8 MPLS experimental bit I used. This, so this is 8, this is 2, this is 5. So we start thinking, what shall we do about quality of service? Because as a strategic solution, maybe within 2 or 3 years, we can restructure the quality of service scheme and rebuild it. But for the time being, when we start the merge, we need at least to do the mapping. So shall we do the mapping here on the PE or the core or ASBR? This was a no-brainer, and for sure, it's the best place to do the remapping. We decided to do it on the ASBR. So the quality of service remapping was done here, and we need to make sure specifically here for this service provider, we had to change the existing quality of service scheme a bit, at least to allow the other classification to pass here. So even if this service provider doesn't have business, doesn't have video, and so on, within the core itself, not on the PE, within the core links and between the core and ASBR, we have to cater for this new MPLS marking and change the queuing only here. But then all the mapping from, as example, service provider 2 to service provider 1, we have to do mapping in this ASBR from SP2 to SP1, and on the return traffic, we have to put it back from SP1 to SP2. So for each ASBR, we have to do a dual mapping from ingress to egress, and from the other direction, from left to right and right to left. So that was one of the main points, and this is how we address it. The second point, maybe I will ask a question to you, Orhan. If you have your house and your front door, how many locks you will put on your front door? Will one lock be enough? You are being very cautious and putting 2, or maybe you are paranoid and you are put 4 locks and 4 control in each door in your house?
0. I trust my neighbors.
Yeah, this was an approach. I like it.
BGP is trust-based. What can I do? BGP, you can advertise anything. So
exactly. So because of that, now let's say these were 3 different service providers, but at the end they are merging into one company. So when we start thinking about how to do the control of advertisement and how to do the trust of this BGP session, for sure we can apply some BGP security like MD5 authentication, we can apply TTL propagation and all these nice features. But what about the advertisement? Shall I put a lock in each place on my network? As example, I will put a check here on the PE, another check on this ASBR, a third check here, a fourth check. How many locks we can do?
How many
so
what?
To be,
but by the way,
how many control? How many control I'm considering like a lock or like a security lock? How many lock we can put? Yeah. So we have decided that
you are talking about transport security with the BGP. I mean, like MD5, SHA, etc. between the BGP neighbors.
Yeah, this is one point for security, but also I'm talking about a simple point: how to trust the advertisement from your neighbor. So let's say this PE is advertising its loopback, and this ASBR will take this loopback and send it to the other domain. shall this domain just believe all this advertisement from service provider number 2, or shall we include some level of control? And this level of control, shall we apply it in each PE or only apply it on the ASBR? So this is the difference between the company culture. Are they risk taker? Do they have a trust for the other domain? Or we need to be very cautious and implement some security safeguard. So this is what we have decided to do. We decided to do all the control on the ASBR layer. And we try to do the control, as example, when I advertise on, let's say here, when I advertise my prefixes, I have to be very specific. So we applied a very controlled fashion on the egress way when I advertise prefixes. So we put each loopback specifically. But when I receive this one, because I know I'm implementing this security in coordination with other service provider, so I will trust this ASBR advertisement, but I will implement what we call it some safeguard. So here I will tell, I will not accept any default route into my BGP. I will not accept any internet BGP, because if somebody do a mistake here, I don't want to accept it here. And after that, I will accept whatever loopback subnet I have. So what I mean to advertise here, that when you think about control, you have two ends of the game. You can be very trustworthy, and whatever everybody will send to you, you can trust it. So you apply zero control, or you can apply maybe 10,000 control and be very specific.
Yeah, but some simple control definitely should be there, and you wouldn't do. Let's talk about some pros and cons of doing on the PEs versus ASBR. You want to do this kind of BGP security not for the transport only, but for the information security as well. Like I'm talking about RPKI, BGP-sec, etc. So you will do at the edge because less number of devices you are dealing with. And those ASBRs anyway connecting those domains. So from SP3 point of view, first devices which is connected to SP1 are those ASBRs. And if you prevent the issue on the edge, so you are not anyway sending back to the PEs of SP3, so you are protecting them. But here, that's why we call it generally edge security, and think about like when you do RPKI, where you connect your RPKI validator, you connect to the internet gateways. So what's the reason? Because those devices, when they receive, they will check who is the prefixes and who is the originator of these prefixes, which AS is the originator of these prefixes. When the validator says, okay, this is invalid, you reject, or maybe you reduce the local pref, so you reject them and then you send to your IBGP neighbor, which means you do the policy at the edge, so less number of devices to touch with, and anyway you are not sending unwanted prefixes back to your PEs or RR clients, etc. Good point.
Exactly. So this, just to summarize, this is what we have decided. We don't want to do zero control, and we don't want to be paranoid and implement control everywhere, because this will be very difficult to maintain. And in case of there will be a change, we need to touch every PE on the network. So we decided to do it on the edge. Not only that, we decided to have some smart way. So as I mentioned, we will not provide strict control in each layer because we are managing everything. So we'll provide strict control. We first advertise our PEs, but the router receiving this, he will just implement some safeguard, and then he will trust my advertisement if it's fall under the PE global prefix list. So that's why it was very good decision and make it easier to follow. The 2 points which we will cover. Can you see my screen now?
Yeah.
The RSPTE.
Yes.
Yeah. So then we have that's why I want to link RSVP TE usually to SLA. It depends how the service providers sell the service to the end customer. So, as example, if the service providers sell the service to the end customer and tell him, I have 95% availability and I can reconverge in case of failure within 2 minutes, it will make it easy. But if you have some critical customers specifically for service provider 3, where he has some business customer and some of them are very critical customers, and they requested some very strict SLA, and for network failure, it should reconverge within a couple of 100 milliseconds up to maximum 200 milliseconds. That's why they start implementing RSVP-TE. Then, once the merge was planned to happen, they start asking us a question. Let's say we will have the merge, and I have a critical customer here on this PE. And then I found that this critical customer will have a new office, but it's very close to this PE on service provider number 2. Will I be able to give this customer the same SLA end to end? And maybe the first answer will come to your mind is no, because these are different IGP. I cannot extend the requirement from one domain to the other. So initially we told them it will be not easy to be handled. We cannot reach up to 50 milliseconds specifically because we have, as you can see here in this area, we have only BGP, and it depends on how BGP can converge fast. This will limit our overall SLA. So we tried to do some tweaking to BGP, and I saw some of the session between Orhan and Jeff, and I agree. Now a lot of service providers implementing BGP event-driven next hop tracking, fast external failover, PIC, and all this nice feature like PIC, as I mentioned, next hop tracking, BFD. So with this feature, we are able to limit the failure within the BGP domain up to a couple of hundreds of milliseconds, 200 to 300 milliseconds. By doing this, we didn't reach the same SLA as 50 milliseconds, but we told them maybe the next step is to start thinking about PCE. So if we have a PCE controller, and we start deploy maybe like BGP-LS from this domain, and then we ask this PCE to push this RSVP-TE, we can reach what we call it inter-domain traffic engineering, and it would be meeting the SLA.
Okay.
But for the initial deployment, we did some tweaking to the IGP and BGP to make sure that the convergence will happen within a couple of hundred of milliseconds.
Okay. Let me go through. You were doing basically fast convergence tweaking, you say, because tweaking, which means changing some parameters, LSA, LSP, because OSPF they have, ISS they have in different domains. So LSA, LSP throttling, those kind of timers reduction, they are doing tweaking. So fast convergence we call it. Not even fast reroute like LFA, remote LFA, TI, LFA, etc. inside the domain, right?
Exactly.
Okay. Now the question is, if you will guarantee, let's say 200 milliseconds, less than 200 millisecond convergence end-to-end, which means SP3 PE to SP2 PE, and in the between we have SP1 domain, right? So
yeah.
Where are those SPs? You don't have to say, of course, the country name, but all those service providers, 3 of them in the same country, or one of them in UK, another in like US. So we have transatlantic, so we have around 120, 140 millisecond latency anyway, propagation delay distance-wise. So are they in the same country?
No, they are the same continent. So they were in Europe.
Europe, but different countries. If it's Europe, if it's Europe, still propagation delay is not a problem.
So, So let's say it was covering the whole Europe. So okay. France, Germany, UK. Yeah.
Okay. Because the reason of this, whatever you do, fast reroute, deploy RSVPT, fast reroute with the PC. PC stands for Pet Computation Element, by the way, guys. It's important thing. We need to just maybe a couple minutes explain PCE, PSAP, and PCC, what they are, these things. But the idea, if one of those service providers, SP3, would be in France and SP1 in USA, so you end up anyway like at least couple hundred, so 100, 140, 150 millisecond propagation delay latency, because don't forget every 1,000 kilometers at 5 millisecond latency, speed of light, so you cannot change it. Anyway, let's continue.
Yeah, thank you for that, Orhan. And this also will, one point I was planning to discuss it, but yeah, it's good time now. Here I'm just presenting, as example, 2 ASPR per domain, per service provider, sorry, and per autonomous system. This is not actually how we did it, because as when Orhan was start talking, I realized that I didn't talk about this point. These peering points or the ASPR location, I spend a lot of time to make sure that we need to put multiple ASPR per country, as example, or per region, to make sure we are meeting the SLA. So, as example, if we put only one ASPR between service provider 1 and service provider 2 in UK, this means that all the customers, as example, in Czech Republic or Russia or this far distance, we need to travel all the way to London and back. So based on this geographical coverage, we had to decide how many peering points we will put between these 3 service providers. So maybe we started with 8, we did some analysis, we did some testing, then we realized we need to add another peering point. So as I mentioned, this is just a sample drawing, but in the real life, we did multiple peering points between service providers. And just to conclude this point, for RSVPTE, we did some enhancement to the BGP and the local IGP. We told them you can still sell traffic engineering within the domain with the very strict SLA, 50 millisecond, but within, if the service will traverse multiple domains, try to make the SLA couple of hundreds of milliseconds till we will be able to do the PCE solution.
So let me add one thing here, actually. Let me add one thing before we continue. He said about the peering points, number of peering location is much more than this, because for the simplicity, we are showing this topology for simplicity only, but for in real life, much more connection. And don't forget, guys, when we have multiple peering points, like even in the real life settlement free peering in the IXP, why we join to multiple IXPs, especially large providers, hot potato routing. So if my customer France and destination is France, and if we don't do peering in France, and in London, if we are doing that, France to France customer, even in the same country, 2 different service providers, their customer traffic will go to another country and come back, and return traffic also would go cold potato routing. But if we connect directly in the same country, maybe a little bit costly, number of devices will increase. There is always pros and cons, but at least hot potato routing, so you don't have to travel to the far distances. Okay.
Exactly. Yeah. Let me show you last. Yeah. Another requirement or another. I need to go to pointer. Yeah. Okay. Can you see my screen or?
Not yet.
Yeah.
Yes.
Yeah. So IGP.
AIGP. Accumulated IGP. Ramiro, listen this.
Ramiro, I use this feature as well in data center.
So in data center, they use a very similar feature, Met Plus. Everybody knows Met BGP Met attribute. Met Plus, normally Met is not additive, but Met Plus was additive. And in one of our videos on YouTube channel, which we will also upload this video on YouTube channel as a real life service provider design scenario. So there was one real life financial network design scenario with Ramiro we did. and they used MED plus feature, which is equivalent of this AIGP, accumulated IGP. Let's talk about this. This is interesting.
Yeah, great. So so when we talk about this AIGP, what is the requirement? So here, what we are trying to do, we are trying now with BGP-LU, thanks to it, any PEs will be able to reach any other PEs in any other domain using the eBGP. So what's happening that using the iBGP-LU, I will start learning about my next hop. Let's say this is PE3 and this is PE1. So I will get the information about PE3 from my ASBR, and I will using my BGP selection criteria, I will start checking, do I have any weight, do I have any local preference, what is the IGP metric, and so on. I will do my selection criteria. Then the final thing, if everything is okay, I will use maybe my local IGP as a tiebreaker. So I will decide in order to go to this PE3, I will follow this link. So I will send the traffic to the PE will send it to ASBR, it will follow all the upper link till it reach the destination PE. Using this, because I don't have full visibility, my decision will be not optimal. It may lead to suboptimal decision, because the optimal path should be the one at the bottom, because as you can see here, even this is 20, but the end goal is here, this metric is 200, so it would be better if I use the lower or the down link. So in order to achieve this, BGP has developed a feature called accumulative IGP. It means that when BGP, when this ASBR sends the prefix of this PE, it will include as well the metric to reach it. So as example, this ASBR, he will say, in order to reach this PE, use me, and my internal metric is 210. The other ASBR, he will say, let's say this link is not there, he will say, in order to reach this PE, you can use me, and the metric is 320. And it will share this to all the PEs. So each PE will receive this prefix with the internal IGP of service provider 1. Then, in order to do the selection criteria, you will have local preference, then we added AIGP. After local preference, then the normal selection criteria. So if the local preference is equal, I will add the IGP, which I learned from BGP, was 320. To how to reach the ASBR, it will be 110. Then it is, as example, 430. And from the other path is 210 plus 120, which is 330. So this means I will choose the very optimal path in the network thanks to this AIGP. So this was really...
Let me add you. Let me add a couple things.
Yeah, and help us a lot to achieve the optimal path, because, you know, maybe in small network, it doesn't make a difference. But as I mentioned, in our scenario where we have more than 10 peering points, if you choose the wrong peering point, as Orhan said, maybe instead of going from France to London, maybe you will go France, Spain, Italy, and then go back to London. So it will be
those kind of asymmetric routing is very common, and really community etc. also comes into the picture to solve those asymmetric routing. But for the AIGP, let me add a couple of things. Now, why Mohammed did this here? Because we have multiple autonomous systems, right? And we want to have between the multiple autonomous system optimal routing as well. So SP1 ingress PE he shows here, PE3 I think. If it needs to send the traffic to PE something here at the edge of the SP2, so we have multiple paths. We have multiple paths, and optimal routing here from which point of view? IGP cost point of view. It's important. Mohammed Ibrahim, how are you? Close your camera. So let me focus, because optimal routing from IGP cost point of view, which means end-to-end IGP cost, we want to have the shortest one. Okay, so end-to-end, which means SP1 up to the ASBR, from PE to ASBR. Then between the ASBR cost will be added. Then from SP to ASBR to the egress PE of ASBR, egress PE of SP2. So which means end-to-end entire path, if we have multiple, we want to find the shortest IGP cost, cumulative shortest IGP cost. What AIGP, accumulated IGP, is doing, it basically sends IGP cost into BGP and then carry via BGP to the another domain. And now in the BGP best selection decision, we need to change it a little bit, because think about it. What was our BGP best selection steps? Local pref, ASPET, origin, MET, eBGP is preferred to iBGP, and after that hot potato routing, which is IGP cost to BGP next hop. So inside SP1, since everything would be the same, just what would decide to which ASBR as the exit point? IGP cost to that ASBR, IGP cost. And when you look at IGP cost, you can find that this path, this one, is the best at the moment. But you don't know the visibility of the another domain, SP2 in this case. So SP2 IGP cost needs to be sent to here. In this network, without AIGP, MET could work as well. Why? When you receive the MET here, so you honor the MET, and because both of this SP3 and SP2, your administrative control as well, not totally different companies, same company anymore. So you need to talk with them. MET could work. But AIGP would be another solution. They went to this path with the AIGP. Now SP2, let's say, when it sends the IGP cost information, it sends via BGP because IGP is not extended. SP2's IGP OSPF, let's say SP1 ISAS, or maybe OSPF, but totally different OSPF, that one. We are not extending. Between the ASBRs, we don't have IGP. It's BGP. That's why IGP cost needs to be placed in a BGP and then advertised to another domain, and BGP best selection decision should be changed. So this AIGP attribute, AIGP comparison between the multiple paths should be done definitely before the IGP cost to BGP next hop, IGP cost to BGP next hop. So where is the place? You can do it even after MET. But generally, like BGP security, when we have the BGP sec, we also change the BGP best selection decision. This is another topic, but we put it generally after local pref, not before local pref. We want local pref to be the decision point for outbound traffic anyway. So this was a nice feature to use, in fact, for optimal routing even between multiple BGP autonomous systems. Any other thing for this, Mohammed?
Thank you, Orhan, for the further explanation. Yeah, and I believe it saves the days. And just want to add that different vendors even implemented differently. So some of them, they copy the AIGP into another BGP feed. They call it metric number 2. Some of them, they copy it into the mid. So we did also some tweaks to make sure each overall in the whole network, we will get the right AIGP regardless of the vendor. So we have to do some testing, and we have to make sure where the AIGP value is copied per vendor specifically. Just to finish my speak, and I found it very exciting today, and thank you again, Orhan.
Yeah, we enjoyed.
Just a couple of lessons learned. If you can see my screen.
Yes.
Yeah. So let me just reshare it again to make sure it's clear without. Yeah, still there, but okay. Yeah. So I believe that because we have been engaged very early in the project, even for the first meeting with the customer, with the executive, so at least I got to understand what are the business requirements, which I tried to convert it into technical requirements. So this was a key. Another point, based on the customer culture and how risk appetite they are they accepting risk, are they risk taker, or they are risk avoidance, it make a huge difference which solution to choose. And also because we had the time to plan ahead and do some lab testing, do a lot of balance between the different requirements. As I told you, shall we use traffic engineering or not? How shall we do the quality of service mapping? So we can do this, but we maybe in the core we have to combine the control with management. Some of these decisions we have to do some trade-offs and have to give up some features. As I told you, because we spent some time on the testing, when we come to the real implementation, it saved us a lot of headache, and even operation team was very grateful to what we have done. One point we did also, even the deployment and the migration step or the migration approach, we had tested on the lab, and we do it step by step. So, and then we train the operation guys how you should do this migration step by step. So this was also a very good lesson learned. And finally, life is not fair, and you cannot get all what you are looking for. And at the end, you have to maybe give up some of the requirement, at least for the time being. So this is life, and you have to be smart, and you have to use your negotiation skills in order to convince the sales team and executives that, as example, we have to give up this feature for this specific customer after the merge, at least maybe for a couple of months. So yeah, thanks again, and Orhan, back to you.
Yeah,
add something?
Couple questions actually I see in the live audience. Let's answer them. These
Sure.
Can you go back to AIGP? I think Paul was asking about that one. This doesn't take into account load on the links. Isn't there any way to take load into account? There are a couple ways. This one doesn't take the load into account, AIGP, yeah. But we have EPE, egress peer engineering. So with the EPE solution, we take of course those not only the ASBR to ASBR links, but also internal load into an account. What else? Ramiro has a point actually here. Also, AIGP needs an IGP to become the seed, but MED can be deployed with IGP-free design. So, but in your case, Ramiro, you were using as an IGP, as I remember, the IGRP, it was there, and still you had MED. So why you didn't use the IGP then? So, but this is another good discussion would be. So what do you think about this load thing? Do you want to add anything, Mohammed?
Sorry, what?
Load. Paul was asking load. It doesn't take into account this load, and I was answering as EP can be an answer for
correct. So for sure it wasn't taken into consideration, but we saw that traffic engineering can help in that, and also maybe in the future segment routing. Because segment routing can consider performance management, including the load, the delay of the links. So yeah, it can give you
another question.
More insight about. Yeah.
Jatil says all service providers are using different IGP. So how you mapped ISS metric with OSPF metric? They don't have to map at all, because what they are doing, ISS metric, they are carrying into BGP, OSPF metric, they are carrying into BGP as well, and then BGP is deciding which path is the best.
Yeah, and because it's it's like a reference. So, as example, if in service provider they are using the metrics in the range of 1,000, while here in the middle in the range of 10, overall when you calculate the sum from service provider 2 point of view, it doesn't matter if it's 1,000 or 100. It's the matter of which one is less metric. So I mean, you don't need to unify the metric. You don't need to change it. You're just taking the sum and comparing the cumulative metric you are learning from different ASBR.
Any other question? Otherwise, we will finish the today one, and we can plan. In fact, we have some plans to do more session in Mohammed. So we can announce in our Skype engineering group. On Skype, we have network engineer group. Those audience later on, if you are watching from YouTube, etc., you can add me on LinkedIn, Orhan Ergun. Mohammed, also you are using LinkedIn, I think. How they can reach out to you later on?
Yeah, I think LinkedIn is the best way. Yeah.
Okay.
You can just share Mohamad Radwan, you will find me easily.
You can reach out on LinkedIn, guys, and this video will be published on YouTube channel. So if you have question, please ask under the video. We will be answering your questions. And as I said, there will be more real-life discussion with Mohammed, with the other engineers as well. So this weekend, by the way, on Friday, sorry, we will have a discussion with the inventor of Lisp, Locator and Identity Separation Protocol. As you know, Dino is the inventor of the Lisp. Experimental RFC is this. We will talk about that. And real-life design discussion will continue as well. So stay tuned and like and share this video if you found this useful. And I enjoyed. When I enjoy generally Mohammed, people enjoy as well. I don't know why.
Yeah.
So yeah, it was nice. It was knowledgeable. It was really knowledgeable. Sorry, go ahead.
Yeah, I said thank you. You make it very exciting, and you had a lot to the discussion with your notes, your questions. Thank you, everybody, and hope it was useful. And if you like it, myself and Orhan, we have a list of other real-life projects which we can talk about.
Yeah. Okay then. Thanks everyone. Last thing, don't forget to subscribe to YouTube channels and stay tuned, guys. Bye.